In the previous video, we developed simple proportional sequences. For this video, we're going to use the 1:2 ratio to design the elevation of a simple house. The intention is to have all the elements relate to each other. There are several ways to accomplish this, with a T-square and triangle, on graph paper, or you can just eyeball the right angles and use a compass for consistent measurements. The first method is using a T-square and triangle. This will assure accurate results and square corners. The size of the square is arbitrary. Set your compass to any dimension. This will assure consistent height to width. Next, draw diagonal lines from corner to corner. This establishes the center point, and you can also use these diagonals to verify that they are exactly the same. This tells you that your corners are square. Use the center point with vertical and horizontal lines to divide the square in half, vertically and horizontally. Continue this process with each successive square that you create. Notice that for each square, you're creating a new 1:2 ratio, a new square that is a 1:2 ratio to the previous square. Using this as a template under tracing paper, sketch directly on top of this pattern and begin creating your simple elevation using these ratios of 1:2. Try to keep the spacing and all the elements within a 1:2 ratio. Make a point that nothing is arbitrary. You can also accomplish this by using simple tracing paper and just counting over squares. Begin with a larger number that's divisible by 2, and then continue to break that square down. You can also do this by just eyeballing square and using a compass to give you consistent dimensions. You'll find that you can eyeball the vertical and horizontal lines relatively close. begin by demonstrating the 1:2 ratio of the front door. Also, a clerestory window has a 1:2 ratio, height to width. Spacing on either side of the window has a 1:2 ratio. Our roof width to height is 1:2. The width of our house is 2. The total height of our house is 3. So here we have a problem. Instead of having a unified elevation with everything of 1:2 ratio, our width to our height ends up being a 2:3 ratio, disrupting the whole overall unification of our ratio. That leads us to other ratios. Of course, there are many other ratios, and these ratios can easily be created stepping off dimensions with your compass. One to 3, 2 to 3, and 3 to 4. What happens if you have a set dimension and you can't step off of whatever length you want? One simple way is to use your dividers and step it across guessing. If you're short, add 1/5 the smaller length. It's much easier to discern 1/5 from the smaller length. And with some practice, you can divide up a specific length into a proportion, any proportion you want, very quickly. Here we've divided it up into 2 to 3. Another method for dividing a specific distance into a ratio is using a mechanical method. This will again produce a 2 to 3 ratio. So the question arises, why use one specific ratio over another, and how do you pick one? In the next 5 videos of this video series, we will discuss the pre-industrial proportioning sequences that Ching discusses in his textbook.